Hi, everyone, and welcome. My name is Kira Garfulo with Greenville Tech's MAT-155. Today we're going to cover Unit 1, Section 3, Variables and Formulas. So first, let's talk about what a variable actually is. It can be a scary term if math isn't your thing, but really it's just a placeholder. It's a letter or sometimes a symbol that can represent a number. Sometimes, most often, we use X, but it could be X, it could be N, A, B, any letter that we can think of. Sometimes we even see Greek letters or symbols. A variable, again, is just something that we don't know. We'll represent unknowns later in the course with variables. For example, if we wanted to write 3 times a number, we don't know the value of a number. So we would write this as 3x. 3 times some number x. Now, just some words of caution here. We have to be careful. Uppercase and lowercase can matter. If in one expression you have a lowercase a and an uppercase a, for example, they may not represent the same thing. They could be two totally different variables. So just make sure that you're consistent, especially if you find yourself typing somewhere. A little a and a big A or a big X and a little x may not be the exact same variable, so just pay close attention. Same thing with subscripts. Subscripts are these little numbers here at the bottom of the x's or any other variable we're using. We'd have x1 and x2. x1 is a totally different variable than x2. They could be totally different variables. They could represent different observations. Either way, they're representing different things. Just because there's an x doesn't mean it's the same number. Let's get some practice here. So now we see 3 more than a number. Remember that we want to let a number be x. And 3 more than that number, what would we do? We would add 3. So we could say x plus 3 or 3 plus x, because remember those are the same things. Either way, they would be correct. So 3 more than tells us we're adding 3, and a number is our variable x. Here I've used x, but you could use y. You could use really any letter that you wanted. I'll typically just use x. Now we have 5 less than a number. So a number, again, is x. And 5 less than means that we need to subtract, because less tells us we're subtracting. So we have our number, and we want 5 less than that. So we're going to take minus 5. Be careful here. It is not 5 minus x, okay? We want the number, and we want 5 less than that number, okay? You can always think about these to double check yourself with real numbers. 5 less than a number. Well, let's start with the number 10. 5 less than the number 10 would give us 5 again. So 10 minus 5 would be right. 5 minus 10 over here on the wrong answers would be incorrect, because 5 minus 10 is negative 5. So just keep that in mind. Now we're going to make it slightly more complicated with 6 more than twice a number. Take these one bite at a time, okay? Twice a number, 2x. We're taking that number x and we're taking twice that. 6 more than means that we are going to be adding 6. Now again, you could have that also equals, you could go either way, 6 plus 2x. Remember, addition can go in either order. So 6 more than twice a number is 2x, and we're adding 6. Now, 7 less than twice a number. So we have twice a number again, and 7 less than that. Just like before, if we have twice our number and we want 7 less than that value, we need to subtract 7. Again, don't put them in the other order. It's not 7 minus 2x. It's twice that number, 7 less than twice that number. So twice the number and 7 less, okay? So 2x minus 7. Now let's get even more complicated here. The sum is going to tell us to add, of two consecutive numbers. We need to think here. Consecutive means back to back. So 1 and 2, 2 and 3, 3 and 4, and so on. If we want to represent that with x, our first number would be x. Okay, so there's the first number, and we need to add a second number. What do we do to get the next number? Well, we add 1. 2 plus 1 gives us 3. 3 plus 1 gives us 4. 4 plus 1 gives us 5. 2, 3, 4, 5. Those are all consecutive numbers. So our next number is just x plus 1. Now this is completely correct here. You could leave it as x plus 1. You could also simplify that to be x plus 1. You could also simplify that to be 2x plus 1. This right here, unless you're told to simplify, will be full credit. But if you like to simplify and make things pretty, go for it. So the sum of two consecutive numbers would just be x for that number plus x plus 1 for the next one. Let me draw a little arrow down here. Separate that. Now the sum of two consecutive odd numbers. We're going to start with x again, but think about consecutive odd numbers. Now we're not getting into 2, 3, 4, 5. We want odd numbers. So let's start with 3. The next odd number that we have is 5. Then the next is 7. How are we getting from 3 to 5 to 7? We have to skip those evens. So instead of adding just 1, you're adding 2. So there's your first odd number plus your second odd number. That's all. Just like before, you could simplify it out if you wanted, but x plus parentheses x plus 2 is a fully complete answer. Now the sum of two consecutive even numbers is exactly the same. 2, 4, 6, 8, 10, and so on. We're starting with one given even number, and we need to add the next even number, which is still going to be x plus 2. So notice the difference here. Two consecutive numbers is 2, 3, 4, 5, and so on. Consecutive odd numbers is 3, 5, 7, and so on. And even numbers would be 2, 4, 6, and so on. So here you're going up by 1 each time in this first time, but in both of these second cases, you're going up by 2, and that's why we have x plus 2. Now the product of two consecutive numbers, where sum is telling us to add, product is telling us that we need to multiply. We still have those two consecutive numbers. We have x and we have x plus 2, but now we're multiplying them. Be careful here because this is not the variable, this is times. So x times x plus 2, or you could just put them both in parentheses, which is what I prefer. And again, you could distribute that out to be, what would that be, x squared plus 2x, if you really wanted to, but right here would be a good answer. If you need to, remember, you can pause this and try to make more sense of it. Okay, let's do some more. The product of two consecutive even numbers. So before, oh my goodness, I did even numbers here. Let's talk about, I'm sorry guys, let's talk about the product of two consecutive, not even, let's just say consecutive numbers since we just did even a minute ago. We have the same two consecutive numbers, so we have x, and we have x plus 1 because we're dealing with consecutive 2, 3, 4, 5, 6, and so on. And remember, the product means we're going to multiply it. So you could just leave them in parentheses and be x times x plus 1. Okay? Again, I apologize for any confusion there. I can't read. Now, let's switch gears a little bit. 5 more than the square of a number. Start with the square of a number. X squared is a number squared. It's called the square of a number. Notice we're not talking about the square root. We're talking about the square. So x squared. And 5 more than means we're going to be adding 5. So this is going to give us x squared plus 5 to give us 5 more than the square of a number. 5 less than the square of a number is the same thing. We still have the square of the number, but how do we get 5 less than that? Well, we need to subtract 5 away. Just like we talked about in those first examples, be careful. We're not starting with 5 and subtracting x squared. We're starting with x squared and we want to get 5 less than that number. Now, a more complicated example. Twice a number, so 2x minus 5 times the square of a number. So 5 times is 5 times something, and the square of a number is x squared. So twice a number is going to be 2x minus 5 times x squared. Here's our 5 times the square of x, and 2x minus that, because we had the minus there. Again, pause this if you need to pause and make sense. Now, a lot of times you're going to see a problem ask you to evaluate something. And to evaluate something, it just means that you're going to replace the variable with whatever values they give you, and you're going to solve. Plug in the values, plug and chug, right? Plug them in, put them in parentheses in your calculator, whatever you want to do to make sense, and calculate the answer. Most of the time, you'll see evaluate, blah, blah, blah. But sometimes they may use the word find. Don't worry, they mean the same thing. For example, if they ask you to evaluate x squared plus 3y when x is 2 and y is 6, then x equals 2. Anywhere you see an x, you're going to plug 2 in. And anywhere you see a y, you're going to plug 6 in. And you're just going to solve. Plug this straight into your calculator and you should get 22. You can solve it by hand if you want to, too, especially if you're good with offhand math. 2 squared is going to be 4, plus 18 is going to give you 22. Again, if z equals 3x plus 9, find z when x equals 10. Well, now it says find z. So we want to solve for this when x equals 10. So where we see x, we're going to plug in 10. So we're going to have 3 times 10 plus 9. So z is going to be 39. Again, we're just plugging in x equals 10 anywhere we see that x. Let's get some practice. So the first one that we want to do is 2x squared y minus 3x plus 1 when x equals 2 and y equals 4. So let's write all of this out first. 2, x is going to be 2 squared, y is going to be 4, minus 3 times 2 plus 1. So we can do this in our calculator. If I can find my calculator. So we want to have here 2 times 2 squared times 4 minus 3 times 2 plus 1 and press enter. And that is going to give us 27. So if we go back over here, we should be able to say that equals 27. If you're a by hand person and not a calculator person, you can solve it by hand. Or exponents first, so 2 times 4 times 4 minus 6 plus 1 is going to be, what is that? 2 times, so that's going to be 8 times 4, so that's going to be 32 minus 6 plus 1. And so that is going to be 32 minus 6 is going to be 26, plus 1 is going to give us 27. Again, I would probably just use the calculator, but if you like to check things by hand, there you go. Now we need mx plus b when m is 2/3, x is 15, and b is 7. So mx plus b, m is going to be 2/3. This is M. X is going to be 15 plus 7, which is going to be B. Let's just plug that into the calculator because that one's not going to be quite as pretty by hand. Let's clear that earlier one out. Let's say, okay, well, we want 2/3 times 15 plus 7, enter. And it's going to be 17. So this will evaluate to be 17. Pause the video if you need. Make sure you can get these answers. You're going to see things similar on tests and quizzes and homework. Let's get some more practice. Now we have the square root of 2x plus 3y when x is 10 and y is 15. So rewrite it as square root of 2. X is going to be 10 plus 3, y is 15. I would certainly just plug this one into the calculator, right? I can't do that in my head. So we're going to do the square root of 2 times 10 plus 3 times 15 and press enter. And it's going to be the square root of 65. Now remember, if we want to get the decimal version of that, we can hit the convert and it'll tell us it's about 8.06 and some change. So the square root of 65 or 8.06. I'm using that curly equals sign because it means approximately. Let's do one more. The target heart rate for a man, where A is the age of the man, can be given by the formula H equals 0.75 times the quantity 220 minus A. We want to find the target heart rate for a man who is 20 years old. So we want to find H when A equals 20. So we know that H is going to be 0.75 times 220 minus A, which is 20. We can plug that into our calculator. 2.75 0.75 times 220 minus 20. And that is going to give us 150. Okay. Again, make sure you can replicate these. Now, something else we can do to simplify things are adding and subtracting what we call terms. And an expression that consists of a number times a variable is going to be called a term. We've seen these all over already. For example, 2x or 3y squared or 9a. You have a number and you have a variable piece. A number and a variable piece. If we go back here, this was a term. This was a term. Okay? This is a term. This is a term. Lots and lots of terms. Okay? If we want to add and subtract terms, we can combine what are called like terms. Okay? That means that the exact same variable and the exact same power of that variable can be combined. Okay? For example, 4x and 5x, the variable here is x, so it's x in the same time, and they're both raised to the first power. Okay, it's just x. 4x plus 5x would give us 9x's. If you have 4 x's and you have 5 x's, then you have 9 x's total. Think about 4 eggs and 5 eggs. Okay, back to basic addition here. Remember that 4x is just x plus x plus x plus x. And that 5x is x plus x plus x plus x plus x. And if that helps you think about it, if you count total, you'll have 9 x's. Now we cannot combine 4x and 6y, even though they're both 1 power, because x and y are not the same variable. Similarly, we cannot combine 5x and 2x squared, because while we both have x, we have x to 1 power here and x squared here, and that's a problem. So they have to have exactly the same variable and exactly the same power. More specifically, in a term, we have what is called a coefficient and a variable component. Okay? So the coefficient, or mathematically speaking, the numerical coefficient, is the number that's multiplied by that variable component. So here, if we have 15x, 15 is our coefficient, because it's 15 times the variable x. What about here? The term 9x squared, what's our coefficient? Hopefully you answered 9, because that's the numerical part here. It's 9 times x squared. Let's get some practice and simplify each expression. We have 3x plus 2y minus 5x plus 9y. So here we see that we have x terms and we have y terms. So we can combine these and we can combine these. So 3x minus 5x is going to give us negative 2x. And 2y plus 9y is going to give us 11y. Okay? You can write these, if you don't want to jump straight to that, you can rearrange this as 3x minus 5x and 2y plus 9y. If you need to group them like that, there's no shame in there. But it is going to end up giving us negative 2x plus 11y. If you're like me, I don't like starting with a negative if I can help it, so I'll rewrite that as 11y minus 2x. Another example, 4.2x minus 3.1y plus 7.2x plus 8.4y. So I'm going to put circles around our x terms, and I'm going to put squares around our y terms. So we have 4.2x and 7.2x. So what is that going to give us? I'm doing math in my head, guys. Remember, that's tricky. 11.4x. And then minus 3.1y plus 8.4y. So 8.4 minus 3.1 is going to be 5.3y. Again, I'm doing math in my head. Dangerous stuff here. But you can see that we combine the x's and we combine the y's. We have to keep them separate. There's one other thing we can do to simplify things, and it's called using the distributive property. It allows us to distribute, obviously, a multiplied component outside of the parentheses across everything inside the parentheses. So A times the quantity B plus C means that A rainbows to B, and A multiplies across C. So remember, if it's outside the parentheses, it applies to everything inside. So we could simplify this and get rid of the parentheses by saying, okay, well, this is the same as A times B plus A times C. And you'll end up with this. So for example, with numbers, if we have 3 times 8 plus 2, this is the same as saying 3 times 8 plus 3 times 2, or 24 plus 6. Now you could also look at this and say, okay, well, just using PEMDAS, I'd have 3 times 10, which is 30. So sometimes it makes it simpler to distribute and sometimes it doesn't, especially with variables, it can help us to distribute. So in this example, we're going to distribute the 5 to both terms. 5 is going to go to 2x, so 5 times 2x is 10x. It's going to distribute to the y term also. 5 times 4y is going to be 20y. Let's get some practice here. 4 times 3x minus 5. The 4 is outside the parentheses, so it's going to go to everything. So we say, okay, well, this is going to be the same as 4 times 3x minus 4 times 5. So that minus has to stay there. So this is going to be 12x minus 20. Okay. The next one, this 3 is going to distribute. So 3 times 6 minus 3 times 2x is going to give us 18 minus 6x. If you need to pause, that's good. Make sure that you can replicate these. You'll see these also. Okay, let's get a little bit more practice. This is going to combine several things. Here, the first thing we want to do is distribute each of these. Okay, so 5 times 3x is going to be 15x minus 25. And then plus, we can distribute this, 14x plus 6. Now we have one of our earlier examples. We have 15x plus 14x. That's going to be 29x. And then we have minus 25 and plus 6. What's that going to be? Minus 19. 29x minus 19. Now, x minus 0.15x. Think about this as 1x, because remember, anytime we see x, we know that there's just a 1 there. Minus 0.15x. Well, 1 minus 0.15 is going to give us 0.85 x's. If you wanted to work the distributive property slightly backwards, if that helps you, you can say, okay, well, these are both x's, so we know that we have 1 minus 0.15 as our coefficients there. If that helps you visualize it. Now, let's express this using a variable. The sum of a number and another number, which is 5 more than the original number. So we have a number plus a number, but we know that the second number is 5 more than the original number. So let's put everything in terms of an x. So we know that x is involved, and this other number is 5 more than the original number. So what's 5 more than x? Well, it's going to be x plus 5. And we want the sum, so we're going to have x plus 5. You could even put parentheses here for that second number. Okay. If you wanted to simplify this, you could say, well, that's going to give us 2x plus 5. Because combining like terms, we can only combine the x's. What about this one? Expressed using a variable. A number decreased by 0.5 times the number. So decreased by means we're subtracting something. So our A number is going to be x, and 0.5 times the number is going to be 0.5x. So we're going to take our number and we're going to subtract 0.5x. If we wanted to simplify that, that would actually leave us with only 0.5x, because 1 minus 0.5 is going to be 0.5x. Again, pause and make sense of it if you need to. Okay, make a list of what questions you have. If you have any questions for me, give it some thought, and then you can send me an email, or if you see me in class, you can ask in class. We can pick up on this. What you need to do before the next class? Well, make sure that you reference the course outline, right? You're going to have an assignment that is going to be due. And where can you find extra help or more practice? Remember, there's tons and tons of extra practice in your text. There's extra lessons in our Blackboard shell. There's practice test questions in our Blackboard shell. And the Math Center is always available to help. You can always reach out to me also. Send me an email. That's going to be the fastest way to get in touch. I hope you've enjoyed this video, and I hope to see you guys in class soon.